By the way, my name is Dave. I'm Dave Kleiner. This is Justin. So what we're going to be talking about is, I'm going to do a little bit of introductions about Sunayu, who we are, what we do, what our focus is. I'm going to talk a little bit about security frameworks, how they, and how risk management frameworks work a little bit. That's going to lead into more of the military concepts because that's where we actually come from. And then Justin's going to walk into how we've implemented some of those implementation guidelines with SALT. He'll talk about some of what we've done already and what we've been doing. We'll go into a little bit of SaltStack and how we've decided to start using SaltStack as an auditing mechanism. And then we're going to do our little demo, which has some moles in it. Sunayu was formed about 4 years ago by Justin, Brandon, and the COO, Ryan, who's unfortunately not here today. Between the three of them, they have about 50 years of experience working in military IT and DevOps. They formed the company because they kind of saw DevOps as a way to do security and to implement security right from the get-go. So it was security operations before the word even existed. We're a DevOps company. We focus on cybersecurity and big data development. Justin, slide. Justin, our CTO, who's over here, Justin's primary focus is infrastructure as code, automation, and DevOps, and he's a self-described nerd. We try our best to get him out of the house and give his wife a little bit of a breather, but we've been quite unsuccessful at it. So a lot of what you'll see is a lot of his work today. Yeah, we couldn't agree more. Sorry.
She'll watch this later.
We'll get some brownie points. My name is Dave, as I've said. I'm the newest guy. I've only been with Sunayu since about June, but I've been in the IT business, not necessarily the federal sector, for 25 years, doing all sorts of different things: project management, security, network engineering manager, so on and so forth. Enough about us. Thanks. I'm going to start off talking a little bit about frameworks and what they are, because frameworks are what make the basis for managing risk. In the Fed sector, the big framework that's used is NIST 800-53. That document actually leads into a lot of other 800 documents. And let me just read off the slide for a moment, because risk management is what leads into all of these frameworks. NIST describes risk management as the program and supporting processes to manage information security risk to organizational operations, including mission functions and reputation, organizational assets, individuals, other organizations, and the nation. So what's a framework? Unfortunately, with personal experience, I've seen people use framework as a bunch of checkboxes. We're secure because we've checked this box, we've checked this box, and we've checked this box. But in reality, they're not. All they really are ways for you to start framing what your system is doing, what kind of data you're going to have on that system, and based on that information, where you need to start implementing security. Password guidelines, things like that. Aside from NIST, the other ones that you've probably heard of are HIPAA in the healthcare, Sarbanes-Oxley in finance, DSS for the credit card industry. So, like I've said, Sunayu is primarily a military defense contractor. We live and breathe working for our clients are mostly within the military space and protecting their assets. And in that in that vein, a lot of what we do comes from DISA, which is the Defense Information Systems Agency, which is effectively one large IT organization. The catch is, and why this is important, is because where we work, DISA focuses specifically on active combat zones, right? So somebody working in the Pentagon who is in procurement and needs to figure out how to double space, they're not going to call DISA. The lieutenant colonel in Bagram Air Force Base who's trying to make sure that his troops have secure communications back to base, that's who he's going to call DISA. DISA, in turn, puts out their own framework, and it's less framework, and it's more of a checkbox system again. And the reason is because you're trying to protect active warfighters. That's really where DISA's mission comes from. To conduct Department of Defense information network operations for the joint warfighter to enable lethality across warfighting domains in defense of the US. They put out these STIGs, these Security Technical Implementation Guides, and they're strong, very strong lockdown mechanisms. As of July, there were 421 of these. Let me just make a note. The ones we're going to be doing in the demo a little bit later, these are only for Red Hat. Red Hat CentOS 7. There are 230, something like that, and they're divided into categories. Category 1s are the highs, category 2s are like the mediums, and category 3s are the lows. For the demo, we're only going to be showing you the category 1s. So after what we used to do, right, when we had an enterprise, is we would pick a machine or pick a handful of machines in our enterprise. Whether that's, so we've got an enterprise of 100, 1,000, 10,000 machines, we'd pick 1% of them, 2% of them, and we'd scan them. And then we'd say, either we're secure or we're not secure. Well, there's problems with that, obviously. Only securing 1%, you're guessing or hoping that the rest of your enterprise is secure. The other problem with it is timing. How often are you going to do this? Because you're always going to have drift. You're always going to have updates that introduce new issues. You need extra personnel. You need custom parsers. Software is expensive. So in light of all of this, Justin, in light of all this, Sunayu said, well, is there a way that we can wrap this all up into one package? And that was Salt. Justin. Flip. So I'm going to hand it off to Justin right now. And Justin's going to go into a little bit more about how we've implemented those DISA STIGs with Salt and how we're using SaltStack to do auditing.
Hey, can you guys hear me okay? So we were a bit surprised this morning with the SecOps Salt E stuff, and that's kind of what we're doing now. So we just kind of wanted to show the way we've been doing it for a while and just kind of our approach to that similar system. And again, we're very focused on the warfighter, and in this specific example, we're very focused on CentOS and Red Hat and how we handle that STIG and that whole process of keeping everything in compliance. So with that in mind, let's continue. So why do we use Salt? Well, we use Salt for a lot of reasons. My favorite reason we use Salt is because, like most configuration management systems, easy stuff is easy, but with Salt, hard stuff isn't that hard once you start learning how Salt works. Some other configuration management systems, as you kind of get past the simple examples and you start moving into the harder things, sometimes very simple things can get very crazy, very fast. With Salt, I never felt like that's an issue. It's like once you understand the basics, then there's always some piece that you can write or fit into whatever you're trying to do to make things work. We also really enjoyed that it's completely Python, so anything you need to write, you can just write it in Python. We can put all of our system states or the compliance STIGs inside of a Salt formula, keep them all in the same spot, especially great for our Red Hat CentOS stuff. We also really enjoy that it works with Windows. We do a lot of Windows hardening as well as switches. So we can basically use Salt for everything, and it also scales really well. So we don't need to worry about any of that stuff. It basically works with everything that we do even custom hardware and stuff like that. Another great thing about it is we can use it with a master, without a master, using SaltSH, or using just salt call to run it locally. So it's very flexible. We've never had any issues with it in the years we've used it. We absolutely love it, which is why we're here today to give our little story. We also use it for not only remediation, but also scanning, as we'll get into in a little bit with SaltStack, which is a execution module, custom execution module in Salt. So first, we're just going to do a little terminology review, just kind of get everybody on the same page, because we'll be using these terms later, and I feel like you can't move on without defining them. So a salt state is basically just a little configuration in your system. It's usually like a package to install or a configuration file, service to start, that kind of thing. High state is a collection of those states for a specific minion. A lot of times you'll use high state to pull together all the states and formulas that you'll use for a system. Formula is a collection of pre-written salt states. We usually try to keep our formulas to very specific software. So for example, we'll have like Apache formulas and stuff like that to keep all of our states that are related to one application or something similar inside of its own directory and its own formula. We also use pillar a lot, which is data assigned straight to minions. You can use this for pretty much anything that you need to seed your formulas with, that it could be minion or cluster specific. An example of this is if you wanted to run a different version of something on one cluster versus another, you could just give the two clusters different pillar variables for their versions and then run what you need. Grains, which is minion-specific data. Examples of some grains are like what the minion's IP is, what OS it's running, that kind of thing. Execution modules. Execution modules are basically like the workhorses of Salt. They are what does all the heavy lifting in the back end and all the Python and stuff that will do what you want to get done. And the reactor. The reactor is a system that's built around Salt's eventing so that you can handle events, process events, trigger things. We actually did a lot with the reactor in our last talk last year when we were doing Docker Swarm autoscaling. We also had Andy the Whale for our demo, so if you want to go check that out, still pretty cool. So moving on. So what we did, we have all 200 plus Red Hat STIGs for the current version of Red Hat 7, CentOS 7 on our GitHub, and it's all self-contained into one formula. So we account for every single STIG in the formula. It's currently being used in several projects. We've used it for a long time. We decided to just open source it because it seems like everybody's using it, and we just wanted to share what we were doing with everybody. And we're really proud of it. So if you guys have any issues or suggestions or whatever, let us know. We'd love to hear from you guys. So let's get into a couple highlights of our formula. And again, this is all online on Git, so if you want to check it out, you're welcome to go look through everything. One of the things that I really wanted to do was, it's called fancy configs here, is we've used a lot of configuration management tools in the past, and in our environments, sometimes they need to be, the state needs to be enforced quite regularly, in the cases of maybe every couple minutes, something like that. And the difference between production and dev environments used to get very difficult because generally we would just clobber the entire config if we needed to write some values. So with Salt's file replace, we're actually able to target just the key value pairs and variables that we want to change and leave everything else alone. And this has been awesome for us. We can use it for, like I said, we can use it for both production and development. We can only make sure just the required setting is set. We don't clobber the whole configuration file. And we can also wrap it into macros so that anytime we want to change any configuration file or value, we can just add it to our little macros and away we go. So I have a little example here. This is just to set a value in the SSHD config. So we made a little macro here, which just takes a key and a value, and then it makes sure that those are set in the configuration file. If they're already in the configuration file, it will replace the value. If they're not, it will append it. And then you can see at the bottom right, we're setting permit empty passwords to no. So this will just make sure that if permit empty passwords is anything but no, it will rewrite it with permit empty passwords no. And then you can see down there too, there's a watch in block, which will restart the SSHD service to make sure that it's there. And anytime we have a bunch of these configurations, they'll all be set. So the other thing we wanted to highlight was how we were talking about before, how hard things still really aren't that hard. One of our requirements was to go through the RPM database and find any issues with differing modes, users, and groups, and then look up the packages they belong to, and then reinforce that those have been reset to their default values. And just by trying to do that normally, that would be a little annoying to do, but if you wrap it into an execution module using some of the existing execution modules of Salt, it's quite easy to do. Just run a command, get some output, run some other commands. And so what we're able to do is basically write a custom execution module to do that for us, and then we can just call that using a state. So our state at the bottom there will look for anything that has a differing mode, user, or group from any of the RPMs installed on the system, and it will reset them to the default values if this is called. And the last thing we wanted to highlight with this was the Phipps compliance. So Phipps is a security standard that needs to be applied to all systems and some of the stuff that we do. Enabling Phipps has quite a few steps to it, including like installing some packages, disabling some things, generating new configurations, and adding extra lines. And this is another case where a file replace with some fancy regex really helped us to automate this much easier than we were able to do in the past. So in this example on the right, we are able to look at the grub command line Linux command, and if no USB does not exist on that line, then we can add it, and then regenerate our grub configuration if needed. And another bit more fancy one is, this one was a very big deal because if you screw this up, you have a non-booting system. So one of the things we do is using custom grains, like the boot devices and root devices. So that way, if there is a difference in the boot device and the root device, then we can make sure we add extra parameters to the grub command line here as well. And you can use variables in your regex. So it looks a little crazy, but basically what we're doing is just adding another configuration option, boot equals whatever the STIG boot device is, if the STIG boot device does not equal the STIG root device. And then that kind of rolls up into all the other configurations before it and kind of appends to this grub line for us that can basically just add all the requirements for us. So that goes over how we do remediations and enforcement. But what about scanning? A lot of people could just say, well, why don't we just run your formula, right? And then if the formula runs, then you're in compliance. Well, that's not necessarily true, and especially in our case where there's like 200 some checks, where some of them might not have a specific state to enforce it completely. But the main reason is you really want to know what's going to go on with your system before you run it. So you want to know kind of how your system stands first, and then maybe you only want to run certain ones of those states. So you could run everything, but if you only have like an insecure SSH configuration, then maybe you just want to run those and only worry about those. So we felt like we needed something else to scan, and we also wanted to keep it in Salt, essentially. So, introducing SaltCheck. There was actually a presentation on SaltCheck last year by William Cannon, who's probably here right now. He's over there. I see him right there. So you can ask him for all your SaltCheck questions. It's actually been part of Salt since 2018.3. The latest version is available on GitHub. We'll have a link to that later in the talk. That's usually where we keep the kind of latest changes that hasn't been merged straight into Salt. So if you want the latest version, I would recommend just grabbing it from there to try it out. And what it was designed to do is an execution module that tests the logic of Salt states and high states. And the great thing about this is it's just another execution module. So that means you have all the built-in advantages of pillars, greens, and even other execution modules while you're doing your checks. And these checks are very easy, right? If you just need to check a file is there or a string is there, there's already Salt modules for that. However, if you need to do something a little crazier, then you're welcome to write it in Python and just extend Salt in another execution module that you can just call straight through there as well. This allows us for very clean reporting of compliance, because it's basically just like a little unit test that you get back with everything that you're trying to do and everything that you want your system to be. So we'll go into some basic examples of SaltCheck. Again, there's a lot more. So on the left is a very simple Salt state. We're just creating a file, a temp test, that has the contents of my str in it. And on the right is an equivalent SaltCheck that I wrote, that the first one just checks to see if the file exists, and the second one checks to see if there's my string or my str in that file. So if you were to run the SaltCheck on that system that you ran the state on, then this is something like the output that you would get. So on the left is the standard output that you would get. So it just kind of gives you a summary of the minion that you did, the formula or state that it was in. In this case, it was just t-test, and then a kind of a little, some comments about what happened, like the name of it, the duration, whether it passed or not. And then at the bottom, there's always the test results, including things like execution time, failed, passed. Newer versions will also have percent passed, stuff like that, missing tests, skipped. And then you'll notice on the right, since it's just an execution module, if you need this information in JSON, you just add a -- out JSON, and you can get the JSON information or output from what you just ran in JSON, so you can pass it off to whatever you need to do, or any other external apps or whatever you want to run it with. So this makes it great for auditing. So we can account for all of the requirements in SaltCheck. So all 200 STIGs we can account for in SaltCheck specifically, and if anything is more difficult than a standard Salt module, execution module would let us do, we can just write it and return whatever we want. It's very extensible, because like I said, you can do pretty much whatever you want. It generally runs faster than a state apply. It will not change the system, because we're only running read-only modules. It allows you to scan before you enforce and reuse a lot of existing content. And like I said, it gives us consistent and regular reporting. All right, so now we're going to do a little demo. The reason behind this is because I think STIG and auditing stuff is probably one of the most boring things known to man. So we were trying to figure out a good way of representing this in a way that kind of gets people engaged. And I want to let you know that our demo, while it is very cute and awesome, we're actually enforcing and scanning systems while we're doing this. So we have 3 servers here in our demo. The first one is just a master. It's basically where we're launching all of our salt code from, all of our formulas, all of our execution modules, that sort of thing. It's named Bonzo. We have one called JPJ, which has just a CentOS install with GNOME installed, kind of a base install. And then we have one called Plant, which is a base install, but it has a lot of issues with it because we want to whack more moles on that one. So that one's going to have a lot of issues that we'll be able to show more fixes with. Yeah, good reference, Led Zeppelin reference. So let me swap. Can you grab yours, please? Thanks. Can you guys, nope, not yet. Can you guys see that? Or is it bigger? Is that okay? Bigger. How's that? Better? Hello? Good? Yes? Good? Okay. So we're on the Salt Master right now. This is Bonzo. I just wanted to show that in Serve Salt, we have a bunch of things here. So we have our DISA STIG 7 formula, which is just linked. So I have to do this crazy thing where I link things with Git repos and everything. So it just makes it easier for me. So I have our DISA STIG there. Again, that's on GitHub if you'd like to check it out. And I split our SaltCheck into its own formula just for my organization. You don't actually need to do that. And eventually, we'd like to just combine them so they're all in their one formula with the scanning and remediation. We have some custom grains, custom modules, and then we have a WAMCat1 formula that I made that just has a couple, I split some of the formulas out so that it looks nicer and runs better on our mole demo. So I can show you what I'm talking about here. So I basically split all of our states into their own files and some helper states that I have to make it easier for me to do. So I'll just give you an example of one of these. Which one was I going to show? That was that one. This one. So this is a very simple state here. Kind of goes over the file replace that I was doing before, and in this case, yum just needs to have a certain configuration value, and it basically looks for that. Looks for the local package GPG check. If it's not set to 1, it will overwrite the value with 1. If it doesn't exist, it will append it to the config. So basically, all of the different STIGs that we're doing, and again, we're going to do the category 1. So there's I think there's 29, 30 of those or so, to make it more manageable, and these are like the most important ones for the system according to DISA. So each check is kind of like this. Some of them will have more lines in them, but generally, this is one of the checks. It's a simpler one. All right, so we have our API over here, which is basically just a very simple Python API. The Python's client library for Salt is, Salt's client library for Python is fantastic. So if you need to do anything, you can do that in Python. So that's what we're doing here. I have basically a simple Flask app where I'm going to grab some of the, like what minions we have and what states we're going to run and run salt checks. So we're basically just going to do everything through this little API here for our demo. And then on the other minions here, I just have tailing some of the logs of one of our minions, the JPJ, and our other minion over here, plant, just so that we can see what's happening as we go through. So here's our whack-a-mole. So right now, it does not have anything. So what we're going to do is run our salt check on the minion of JPJ. So we can see over here, if we look at JPJ, it's going to start running the salt check. So you can see a bunch of tests that are going on right now. So this is the minion log on JPJ, and so it's running the salt check. So all 29 of these category ones is going to go through and get a true, false, pass, fail kind of a thing, and then return. So you can also see it over here on the API. Just showing that it's running. There you go. So now it returned. I just have it in debug, so it hits a lot of output. However, now we have a bunch of moles. So what happens is the red moles are a failing test, the green moles are a passing test, and the blue, kind of like mole holes, are a skipped test. An example of a skipped test is like EFI. So in our case, our VMs are not using EFI for their grub stuff. So actually in our salt check, we can account for that, and we can say that, hey, it's not using EFI, so we're just going to skip this test. So that's what these blue squares are for. So what we'll do is go ahead and whack one of these moles. And in this case, this one was the SSH daemon must not allow authentication using an empty password. So what we just did was we made sure that permit empty passwords was set to no in our SSH daemon configuration file. And so we can look over here at our API, and you can see we ran our state. There's actually a lot of output on this because I was debugging, but that's okay. You can also see it here on the minion. This is the minion log, so you can see state was ran and the password was changed, or the configuration was changed here, and SSHD was restarted. And then what we can do is we can rerun our salt check, and now that one should be passing because we ran the remediation. So I'll let that run. It takes maybe like 20 seconds or so, at least on my setup. So you see here it's running a bunch of checks. And in this case, I'm running all the checks each time. I didn't have time to just do individual checks, but that would be faster. So there we go. So the one we just whacked is now passing. So then we thought this was really cool. So now we can, this is basically just a representation of what we're doing all the time, constantly in our systems, is we need to make sure that our systems are constantly in compliance, and if they're not, we need to put them back. So in this representation, we can just start crushing all of our security requirements with whack-a-moles and just making sure every single one is in compliance. There's some grub password we just added. Here's some time logout we just enabled. Just whacking moles down the line. There's some yum configurations we just added. It can be. We wanted to see if anybody was interested in this or not. Maybe we'll share it to Salt Enterprise and see if they want to use it in their product, you know? So what I want to do is go ahead and whack all these moles, and then we'll show you a nice clean system here of all the category ones that have been whacked. Now this last one here is Fips. So the Fips one actually takes a little while. We can tail the minion log while it's going. So it does a couple things, like it does pre-linking, and it'll do some like dract-f kind of stuff. And you'll also see some of our examples before where it will check to see if the boot device and such like that is equal, and if it's not, it will update the grub configuration. So it should come up here in a minute. You should see it start editing the grub configuration. I think this always takes longer in demos. I'm sorry, guys. So we're still running this dracket-f thing here. There it goes. Okay, so you can see there some of the grub stuff was updated. It added no USB. It also added the boot device, which is needed, since apparently in this build it's different. And then it returned. So now we should see a huge amount of output over here. Yep, so this is all the stuff that it did. And now Fips is added in the system. So now we're going to rescan. Now what I'm expecting is going to happen here, and again, because this is a representation of what we're really doing. So Fips is one of those ones where you're actually not in compliance until you reboot the system into the Fips mode. So I imagine the only one here that you'll see that's not going to be passing right now is going to be Fips, which will be that mole I just whacked. And there it goes. So all the other ones are now passing from the scan, except for the Fips one. So we're going to go ahead and bounce this machine, see if we can get a fully happy whacked mold system here. So reboot it. While that one is going, I figured I'll just scan the other one. And it's going to have a bunch of moles that we can whack while we're waiting for the other one to go. Because the animation person we work with named Bridget did all the animations for this, and they're fantastic. So. This one's still going. Oh, there it goes. Sorry, it returned. Okay. Yeah, so you can see this one has a lot more issues. But we can do the same thing, and we can go through and just whack each one of these. And again, it's actually setting it on the system. So it's running the salt state that's equivalent to the STIG ID, the rel 07 whatever number. And just, we're hardening our system as we go, whacking those moles. Like this one, RSH server is installed. We don't need that, so we're getting rid of it. Whacked. YP server is installed. We don't need that. That's a security issue. Get rid of it. Whacked. So let's go check on our JPJ. That one should be up now. Let's make sure I can hit it. Yep. So we'll rescan that one. And we're rescanning a different minion. I tried to put some debug output at the bottom there so you can see which one's there. But we threw this GUI together in a day or two, so sorry. So when this comes back, we should see that all of the moles are very happy and the system is completely in compliance, or at least the category ones. So I'll just tell the log so we can see what's going on. Usually when I do this, it finishes and then I wasted my time. I think it did. Yep, there we go. So there you go. So our minion JPJ now is completely happy. All the moles have been whacked. Everything is good. It's in compliance. And again, these ones up here were skipped because they don't apply to the system. And then we could also just run the check on that one. So later we can whack some more moles. So that's the demo. Let's switch. Got too much in the demo, Dave. So that was a little demo of what we're currently doing on several of our projects. We also do things like we schedule periodic scans to make sure we're in compliance. Some of our customers actually want real-time reactions to those scans where we can just apply the checks right away to make sure that anything that's drifting is set straight back to where it is. We could even do reporting with this. A lot of the salt check output reports we do and just kind of make them look prettier to send off to our security people. I wrote this before we knew about the Salt Enterprise Security Center thing, so technically we could use that too, or we could even integrate to it. Maybe they want our whack-a-mole UI, you know, for Salt Enterprise, I don't know. But that's pretty much what we're doing, and Salt works great for this, so it doesn't surprise me that they would do it too. It's a great use case. So that kind of wraps up our talk. We have shout-outs for William for all the help he did with Salt Check. We wouldn't be able to do the Salt Check stuff and the scanning without him. He's somewhere in here. I think he's over there. Bridget for the moles, like I was saying, she did all the animations for the moles. I'm not an animator, so that was great. I think she did a great job. All of Sunayu, just for the support, just sharing with us one of our use cases and making it look like a fun presentation to do. And then everybody else. So you can contact us in a variety of ways. Our website, you can check out our GitHub. We'll probably be posting some stuff from this presentation shortly on there. Just some contact information for us. And that concludes the presentation. If you guys have any questions, let us know. Any questions? Want to see anything else? I'm sorry, say again? No, everything is salt. Yep. No. Yeah, we don't. So, my opinion is, so for me, I just wanted everything in salt, and I felt like salt could do it just as well. So it's something we've used. But again, for some of our projects, we just wanted to keep everything in Salt, and it made it a lot easier for us. So, but you could also do that too. No other questions? All right, well, thanks a lot, guys. Hope you liked our presentation.